Welcome back, everyone. In this video, we're going to look at what we call functional groups. This is that you should be able to identify the different functional groups: alcohols, ethers, amines, aldehydes, ketones, carboxylic acids, esters, and amides, and be able to find them within large organic molecules and identify the structural features of large organic molecules, including the functional groups they contain and which class of hydrocarbon that they are in. So prior to this, when we talked about organic molecules, I mentioned that there are millions and millions of organic molecules. But if it just consisted of carbon and hydrogen, then there would only be so many variations that we could get. So functional groups are what really add the variety into organic chemistry. And it's the functional groups on molecules that make them useful. Due to the functional groups on organic molecules, we have dyes, we have solvents that are used for chemical reactions. Your perfumes are based on organic molecules with certain compounds in them. Medicines, the active ingredient in medicines function through their functional groups. The refrigerants that are used in your refrigerator or freezer have different functional groups on them. Your clothes themselves, foods, the list goes on and on. Pretty much anything that's ever been made or found in nature to have a practical use has one of these functional groups on it that we will talk about today. So what are the different functional groups? Again, these are groups that perform certain functions, hence their name. And we can have cases where there is a group connected to carbon through a single bond. And this is a term that you need to be familiar with: heteroatom. This is essentially an element that is not carbon and not hydrogen. These are, generally speaking, we're dealing with other nonmetals. So commonly, this will involve oxygen, sulfur, nitrogen, fluorine, chlorine, bromine, phosphorus, etc. So we can have, there are 4 groups here to talk about. These are, we have the halides. That includes a carbon with a single bond to a halogen: chlorine, bromine, iodine, fluorine. Alcohols, which have carbons bound to an OH group. Ethers, which have an oxygen sandwiched in between two different carbons. And then amines. Amines are carbon atoms with single bonds to nitrogens, and you can have either 1 carbon atom bound to the nitrogen, 2 carbon atoms bound to the nitrogen, or 3 carbon atoms bound to the nitrogen. And in all of these cases, we use the terminology or the symbol R. There's no element R, and so it's used in organic chemistry to designate a hydrocarbon group. This can be a carbon of any length. It could be any number of carbons and hydrogens that are attached to it. So you could have a structure that looks like this, and then we have a halogen on the end of it, and this is a halide. Or you can have something like this with an alcohol group on the end. That's an alcohol. Okay? So here are some other examples. If we look at ethane and we replace one of the hydrogens with an alcohol group, that becomes known as ethanol. If we take and sandwich in between those 2 carbons the oxygen, then we get an ether, dimethyl ether. And if we replace one of the hydrogens with the nitrogen group, we call that an amine. That's ethylamine. And you'll notice that the functional groups lead to different physical properties. If we take a look at the boiling point of the different substances, we see that they vary wildly with the different types of functional groups. We'll go more into depth about why that is later, but what we want to recognize is that the different functional groups will lead to different physical properties. So now let's leave the functional groups that have single bonds between carbon and the functional group, and now talk about functional groups that have what we call a carbonyl. A carbonyl is simply a carbon-oxygen double bond, and the carbon is bound to some other things. Depending on what those things are, that will give us a different name. So the carbonyl itself is just the carbon-oxygen double bond. So I'm going to circle here now the carbonyl portion of these different functional groups. So if you have a carbonyl that has at least one hydrogen as one of the extra groups, then we call that an aldehyde. This other group could be a carbon or it could be a hydrogen. A ketone consists of a carbonyl group with two carbons on either side. So both of the R groups, if you will, for the ketone must be carbon, but after that, it doesn't matter. For a carboxylic acid, one of those groups is a carbon and then the other is an OH. So it looks almost like we have a carbonyl with an alcohol on it. An ester consists of a carbonyl with a single bond to oxygen, and then on the other side of that oxygen is another carbon, and then on the other side of the carbonyl is another carbon. And then the last group that we're going to deal with is the amide functional group. So that has an alkyl chain next to the carbonyl, and then a nitrogen-bearing group. And similar to an amine, the amide can have varying numbers of hydrogens versus carbons. So let's take a look at some actual examples. Benzaldehyde is an example of an aldehyde because we have the carbonyl functional group and then a hydrogen. We also have formaldehyde, which has the carbonyl functional group and then two hydrogens. Carbonyl group with two different carbons. This is acetone. We then have acetic acid, which is an example of a carboxylic acid. We also have oxalic acid, another example of a carboxylic acid. Benzyl acetate is an ester. We see here the carbonyl with the carbon group and then the oxygen with another carbon group on the end. Ethyl acetate, which is also an ester, and isoamyl acetate, another type of ester. This actually is the main source of the banana smell in the banana runt. And then finally, we can see here amides in the form of what we call a peptide bond. These we find in amino acids, which we will look at here shortly. So proteins are made up of amino acids. There are 20 common amino acids in humans, and they can be organized based upon what we call the side chains. The side chain for all of these amino acids is highlighted in red. So you'll notice that they all have the same essential backbone structure. They have a carboxylic acid and an amine. And when they get combined together, that's when we form the amide bond. Amino acids are also great ways to look at the various functional groups that exist in nature. And so we can classify, again, these amino acids based upon their shape, based upon whether they're polar or not, whether or not they have aromatic side chains, if they are acidic, or if they are basic. All right, so let's practice looking at functional groups. And so functional groups play an important role in terms of how drugs function. In this problem, try and determine which functional group is not present, which functional group is absent from all of these molecules. So each of these will have different functional groups, but there's one functional group that's not found in any of them. pause the video and try and determine this for yourself. All right, welcome back. So on the left, we have a carboxylic acid. We have a carboxylic acid on ibuprofen. There's an alcohol in acetaminophen, an amide in acetaminophen, and an ester in acetylsalicylic acid. So we have carboxylic acids, alcohols, esters, and amides. So the ketone is what is missing. Now, you might have struggled and thought that you had an alcohol here. You don't. When you're looking for the functional groups, you want to first identify any that are carbonyl based. And so you're going to look first for the carboxylic acids or the amides. This is not an amine. If it's already counted in the carboxylic acid and the amide, then we don't double count it for an alcohol or an amine. Okay, let's try one more practice problem. Try and identify which functional groups are present in the side chains of the amino acids. Remember, on this slide, the side chains are all indicated in red. So pause the video and try this one on your own. Welcome back. So we have alcohols in a variety of the different amino acids, indicated here with the blue stars. We also have amine side chains on lysine, arginine, and histidine. And then also within tryptophan. We have a couple of different ones with amides on them. Asparagine and glutamine have amides in their side chains. And then there's a few with carboxylic acids, aspartate and glutamate. Hopefully you were able to find all those. The other side chains, these we can see, these all have alkanes only. This is a side chain we haven't talked about. It's called a thiol, but you do not need to be responsible for it. Okay, that's it for this video. Thanks for watching. Have a great day.